Okay, so we have not done any calculus yet on some of these polar curves. So we want to be able to do things like find vertical and horizontal tangents and find areas inside of polar curves and all of that good stuff. So let's first talk about tangents to polar curves. So if you're given a curve r equals f of theta, well, remember that x is r cosine theta. And that means that if r is f of theta, you can put f of theta in here. So your x is really f of theta cosine theta. And your y is r sine theta. So r is f of theta right here times sine theta. And then you can think of theta as a parameter and just do your parametric derivative. So dy dx is dy d theta over dx d theta. So here's our x. We want the theta derivative of that. So just do a product rule. So here's your f and here's your g. So I've got, or here is your f and here's your g. So f prime is dr d theta times, oh, I'm doing y on the top. So here's your f, here's your g. So f prime is dr d theta here times g sine theta plus f is r, and then g prime derivative sine is cosine. On the bottom, you're doing dx d theta, so that's the product rule on this guy. So f prime is dr d theta times g cosine plus f is r, and then derivative cosine is negative sine theta. So really what this is r sine theta, and you take the prime of that over r cosine theta and take derivative of that, again with product rule. So that might make it a little bit easier to remember. So let's put this to work here. So in example 10, we've got r equals 1 minus cosine theta. That's a cardioid. We want to find the slope of the tangent at theta equals pi over 6. So if we sketch a graph of this guy, actually let me, I'll actually graph in with technology here and I'll paste in. So that graph looks like this. It's r is 1 minus cosine theta. It's a cardioid along the x-axis, negative x-axis, because negative cosine. So we want to find the slope of the tangent at theta is pi over 6. So pi over 6 would be something like this. And we want to find the slope of the tangent line at that point right there. Okay, so this is pi over 6, approximately. I know it looks closer to pi over 4, but I wanted to have something. So we want to find the slope of the tangent line, so that little tangent line looks something like that. So we want to know what's the slope. So here, m equals what? Okay, well, slope is dy dx. So our dy dx is dr d theta sine theta. So here's our r. So r prime dr d theta is going to be derivative 1 is 0, derivative of cosine is negative sine with another negative. This will be sine theta. So dr d theta is sine theta times another sine theta plus r, which is 1 minus cosine theta, times cosine theta. And then in the denominator, we've got dr d theta cosine theta. So that's sine theta cosine theta minus r sine theta. So 1 minus cosine theta times sine theta. All right, well, let's simplify this rascal and see what we get. So sine times sine, sine squared theta. And then let's multiply our cosine in. So we're going to get a plus cosine theta and then minus cosine squared theta. And then the denominator, we've got a sine theta, cosine theta. And multiply this guy in. So that's going to give us a sine theta with a negative, so minus sine theta. And then sine theta, cosine theta, negative. Another negative is positive. So that'll give us another sine theta, cosine theta. So 2 sine theta, cosine theta. So we can move that guy over. All right, so now to simplify, we don't need to simplify this more. We actually can plug in our theta and we'll be good to go here. However, notice in the next part we want to find the points on the graph where the tangent's horizontal or vertical. That means that we're going to have to be able to factor the numerator and denominator. So we want to do a little bit more work there. So what I'm going to do is swap out this sine squared here for 1 minus cosine squared. So this will be 1 minus cosine squared theta, and then plus cosine theta, and minus cosine squared theta. And the denominator, that one, I think if we just take out a factor, we got a common factor here of sine theta. So we could pull out a sine theta. And then we'll have left 2 cosine theta minus 1. And then this numerator, let's see, we've got negative cosine squared, another negative cosine squared there. So we actually can factor that numerator. So this is actually going to be 1 plus cosine theta, and then minus cosine squared, minus 2 cosine squared theta. And then our denominator from the previous steps the same, sine theta, 2 cosine theta minus 1. And so let's see here. Let me give us a little bit more room. So in the numerator, we can factor that guy into 2 binomials. So first terms have to make 1, so that's going to be 1 and 1. Last terms have to give us a negative 2 cosine theta. So that's going to be a cosine theta and a 2 cosine theta. And then we want the outer and inner terms to give positive cosine. So let's see, then that'll be plus 2 cosine and minus cosine. So then last terms give negative 2 cosine squared. Outer terms 2 cosine, inner terms negative cosine, that leaves positive cosine. And then denominator is the same. So that's going to make the next part quite a bit easier. Okay, so now we can go ahead and plug in and get our slope of the tangent at pi over 6. So we're plugging in pi over 6 here, so it's going to be 1 minus cosine pi over 6. And then 1 plus 2 cosine pi over 6. Denominator, we've got a sine pi over 6. And then 2 cosine pi over 6 minus 1. Notice that these two guys don't cancel because that's got a minus sign and this one doesn't. So then cosine of pi over 6 is root 3 over 2, and sine pi over 6 is 1/2. So this would be 1 minus root 3 over 2 times 1 plus 2 times root 3 over 2. That'll be root 3. And then sine pi over 6, 1/2. And then cosine pi over 6 root 3 over 2 times 2 is root 3 minus 1. So there's our slope at pi over 6. So that value is the slope of this line. And now let's work on vertical horizontal tangents. So for the vertical tangents, we scroll back up here for a second. So for vertical tangents, that's when the denominator is equal to 0. So this is 0 at vertical tangents. And then the top is going to equal 0 at horizontal tangents. Because a fraction is 0 only when the numerator is 0, right? Okay, so what we want to do is, for horizontal tangents, we are going to set our numerator right here equal to 0. So set 1 minus cosine theta times 1 plus 2 cosine theta equal to 0. So either 1 minus cosine theta is 0, in which case you can bring that cosine over on the right, get cosine theta is 1. And cosine theta is equal to 1. The x-coordinate is 1 at theta equals 0 or 2 pi. And then, or this piece equals 0. 1 plus 2 cosine theta is equals 0. Bring the 1 over as a negative, divide both sides by 2. So cosine theta is 1/2. And then we want the angles that have x-coordinate 1/2 on the unit circle. So we grab our unit circle here. So x-coordinate is equal to 1/2. That's at pi over 3. And then also at 5 pi over 3. And we only want things that are between 0 and 2 pi. And then we could plug these theta values in to x equals our cosine theta and y equals our sine theta to get Cartesian. So x is equal to our cosine theta and y is equal our sine theta. And you'd plug these guys in to get xy, if they're called for. And then for our vertical tangents, we are setting our denominator equals 0 here. So sine theta times 2 cosine theta minus 1 equals 0. So either the sine theta is equal to 0, in which case theta equals 0, or 2 cosine theta minus 1 equals 0. Let's see, actually, let me bring this up. So 0, 2 pi. 2 cosine theta minus 1 equals 0. So bring the 1 over, divide by 2. Cosine theta is 1/2. And that's going to be these guys again. which shouldn't be. So let's see, look back here. I think we made a sign error. So you shouldn't have your vertical horizontals at the same place. So let's see, 1 plus 2 cosine theta equals 0. Bring the 1 over as a negative. And then, so these won't be pi over 3, 5 pi over 3. Cosine of theta is negative 1/2 at 2 pi over 3 and 4 pi over 3. So these should be 2 and 4. Now we got it. So we know how to find tangents and vertical horizontal tangents. So with that, try WebAssign section 10.3 problem number 10.